Alright, so today we are going to start our new unit, and our new unit is all going to be about solving quadratics now. So, 2 units ago we were graphing quadratics, which were our parabolas. Last unit we learned how to factor quadratics, and now we're going to use a lot of the information from the past 2 units to now solve these quadratic equations. So today we're going to focus only on solving quadratics by factoring. So it's going to take all of the methods of factoring that we've learned from the previous unit, and then we're going to take it one step further. And we've already done this in a way. When we found the x-intercepts of a parabola, we set each of the pieces or factors equal to 0 and then solve for the variable. That's the same thing we're going to be doing here. We're going to take our 2 factors, we're going to set each one equal to 0 and then solve. So that's the only new step that we're adding into our factoring from last unit. So when solving quadratics, we are looking for the zeros, or we also call those the x-intercepts of the quadratic. Now, if you're already given the factors, like if you look at the examples below, it's already in factored form. So when you're given the factors, half of the problem's already done for us. Now all we need to do is set each piece or factor equal to 0 and then solve it. So if I look at the example here, it says solve k plus 1 times k minus 5 equals 0. So here are my 2 pieces, the k plus 1 and the k minus 5. So setting each piece equal to 0, let's start with the first one, k plus 1 equals 0. To solve for k, I would just subtract the 1, and I would have k equals negative 1. Not too bad, right? So let's look at the second piece now. We have the k minus 5. Set that piece equal to 0. Add the 5 over, and we would have k equals 5. So below we have 3 problems. If you want to try them on your own first, go ahead and pause the video. Alright, so it's already factored for us again, so I'm just going to set each piece equal to 0. So here's the first piece, a plus 1 equals 0. Here's the second piece, a plus 2 equals 0. So to solve the first piece, I would subtract the 1. So a would equal negative 1. Over here, I would subtract the 2. And a would equal negative 2. So both of those are my answers. Looking at number 2, first piece is 4k plus 5. Set that equal to 0. Second piece would be k plus 1. So I set that equal to 0. So the first piece is going to require 2 steps. I first have to subtract the 5. So I would have 4k equals negative 5, and then divide the 4. So here I would have a fraction. K equals negative 5 fourths. Second piece, subtract the 1, and this one is nice and easy. K just equals negative 1, and I'm done. Alright, last problem. Start by setting the 2 pieces equal to 0. So 2m plus 3 equals 0. 4m plus 3 equals 0. So this one, they're both going to require 2 steps. So I'm going to have to add and subtract first, and then divide to get the variable by itself. So first we'll subtract the 3. So 2m equals negative 3, and then divide both sides by 2. So m would equal negative 3 halves. The second piece, subtract the 3. So 4m equals negative 3, and then divide off the 4. So m would equal negative 3 fourths. Alright, so now we're going to take it a step further, and we're going to start with a quadratic equation. Then we're going to factor it, and then we're going to set each piece equal to 0 and solve. So if you're given the equation, so if you recognize this, ax squared plus bx plus c, that is a quadratic in standard form. So if you ever see a problem like this with a quadratic equaling 0, you're going to have to factor first. Once it's factored, we'll set each piece equal to 0 like we did on the previous page, and then we'll be done. So remember, first step with factoring, always look for a GCF. So if I look at my example here, I don't see any GCFs. So I'm going to go right into my factoring. If I notice, the x squared term is by itself. So when x squared is by itself, that means I'm going to go right into big X. Okay, a equals 1, b equals -11, and c equals 24. So setting up my big X, c goes on top, so 24. b goes on the bottom, so -11. So just to kind of refresh us on factoring real quick, I need factors of 24. Okay, those will go here. That multiply to give me the top, and add up to give me the bottom. So factors of 24. I have 1 and 24, 2 times 12, 3 times 8, 4 times 6, and that would be it. So I need to find a way to get to 11, -11. So if I look at my choices here, the only way I can see getting to 11 is with the 8 and the 3. But it needs to be -11, so both would have to be negative. So -3 and -8. Always check to make sure the big X works. If I multiply -3 times -8, that gives me positive 24. And then if I add -3 plus -8, that gives me -11. So my factored quadratic would be x minus 3, x minus 8. Now that I have it factored, I'm going to go through and set each piece equal to 0. So I'm going to come over here and do that because I'm kind of running out of room. We would have x minus 3 equals 0 and x minus 8 equals 0. Add 3. So x would equal 3. Add the 8. Or x would equal positive 8. Okay, so that's the full problem. Okay, factor it using one of the methods we learned in the previous unit, and then set each factor equal to 0 and solve. So again, if you want to try the next 3 problems on your own first, go ahead and pause the video. Alright, so again, the squared term is by itself. There's no GCFs in the problem, so I go right into big X. Okay, so here's B, here's C. So C goes on top, B goes on the bottom. So I need my factors of 10. That would be 1 times 10, or 2 times 5. The only way I can see getting 7 is with the 2 and the 5. And let's check. 2 times 5 gives me 10. 2 plus 5 gives me 7, so I'm good to go. So my two factors, n plus 2, n plus 5. Ran out of room. Okay, now setting each piece equal to 0, I would have n plus 2 equals 0, and n plus 5 equals 0. Subtract, and subtract. Okay. Number 5, again, big X. C on top, B on the bottom. Factors of 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Now, here we have 2 ways of getting -10. Okay, we have 2 minus 12 and -4 plus -6. Both of those will get us -10. So I need to look to see what would give me positive 24 when I multiply. If I did 2 and -12, 2 plus -12 would give me the -10, that would work. But 2 times -12 would give me -24. So that would not work. If I did -4 plus -6, again that would give me -10, and then -4 times negative 6 would give me positive 24. So those are the two I want to use. Okay, so sometimes you'll run into problems like this where two things potentially work, so you have to check to make sure that they both multiply and add up to give us what we need. Don't just assume it's the first thing you see. Okay, so our two factors, n minus 4 and n minus 6, setting each piece equal to 0, add the 4, add the 6. Alright, last one real quick. Again, the squared term's by itself, there's no GCF, so this is big X. Negative 18 and 3. So my factors of 18. We have 1 and 18, 2 and 9, 3 and 6. So I need it to multiply to give me negative 18 and add up to positive 6, or positive 3. So here's how I can get to 3. I would need positive 6 and negative 3. Multiplies to give me negative 18, adds up to give me positive 3. So n plus 6 and minus 3. Set each piece equal to 0. Subtract the 6. Add the 3. Alright. Okay, the last few problems here, we're going to make the factoring a little bit more challenging. Again, if you want to try these on your own first, go ahead and pause the video and try what you can. And then watch the video to kind of check your answers or to figure out wherever you get stuck. Alright, so looking at number 7, I see that the squared term is no longer by itself. So this is where I'm going to use the AC method. Alright, so A is 5, B is 7, C is negative 6. So when I set up my big X this time, I want A times C on top and B on the bottom. So A times C, so 5 times negative 6 would be negative 30. B would be 7. So factors of 30. 1 and 30, 2 and 15, 3 and 10, 4 doesn't work, and then we would have 5 and 6. So I would get to 7 using 3 and 10. Now, I want it to be positive 7 when I add, so that means that the bigger number has to be positive. So I would have 10 and negative 3. 10 times negative 3 gives me negative 30. 10 plus negative 3 gives me positive 7. Now, with AC method, which differs from big X, I'm going to take my two factors that I found. I'm going to slap some x's on them. And then I'm going to replace the middle term with the two numbers that I just found, the 10x minus 3x. So I'm going to try and color coordinate this for you a little bit. So I'm not messing with the 5x squared. I'm replacing the plus 7x with plus 10x minus 3x. Because what is 10x minus 3x? 7x. So I'm not changing the problem, I'm just changing how it looks. Then we have the minus 6 on the end. Now, I have 4 terms, so this is where I do my factor by grouping. So the GCF of 5x squared and 10x would be 5x. So divide by 5x. And that would leave me with x plus 2. Looking at the second two terms, I could divide both of those by 3, but because this term is negative, I'm going to take out a negative 3. So divide by negative 3. That would leave me with x plus 2. So my two factors would be the outside stuff, so the 5x minus 3, and the inside stuff, x plus 2. Now that I have my two factors, I'm going to set each piece equal to 0. So 5x minus 3 equals 0, x plus 2 equals 0. Add the 3, divide by 5, we would get x equals 3/5. Subtract the 2, x equals negative 2. Alright. So number 8 is similar in that there's no GCF and the squared term is not by itself, so I'm going to have to do AC method. So a is 3, b is negative 2, c is negative 8. So setting up our x, I want a times c on top. So 3 times negative 8 is negative 24, and it's got to add up to negative 2. So factors of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. So to get negative 2, I'm going to have to use 6 and 4. It would have to be negative 6 and positive 4, right? Negative 6 times 4 gives me negative 24. Negative 6 plus 4 gives me negative 2. So in this case, it's y's. So I'm going to slap some y's here and then replace them middle. So 3y squared, instead of minus 2y, I'm going to have minus 6y plus 4y, and then the minus 8 equals 0. Again, I didn't change the problem. I just changed negative 2y into negative 6y plus 4y. Now I have my 4 terms, so I'm going to factor by grouping. If I look at the first two terms, I could divide both of those by 3 and y. So divide by 3y. That would leave me with y minus 2. Looking at the second two terms, I could divide both of those by positive 4. So divide it by 4. That again would leave me with y minus 2. So my two factors would be the outsides, 3y plus 4, and the inside, y minus 2. Setting each piece equal to 0. I'm going to subtract the 4 and divide. So y would equal negative 4/3. Here I'm just going to add the 2. So y would equal 2. Alright, so that is using the AC method to solve the quadratics. Now we're going to look at my difference of cubes. Okay, so I have subtraction sign in between my two terms. I have 4, which is a perfect square. X squared is a perfect square, and 49 is a perfect square. So let's start by taking the square roots. So that would leave me with 2x and 7. Now, if you remember, difference of squares has this pattern, a squared minus b squared. When I take the square roots, it leaves me with a and b. So there's this pattern, a plus b, a minus b. So I take my square roots, I get 2x and 7. So that's what I'm going to use instead of a and b. One of them has a plus in between, one of them has a minus in between. So 2x plus 7, 2x minus 7. And then it's factored. Okay, that's a lot easier than AC method, a lot less steps. Setting each piece equal to 0. Subtract, divide, add, divide. Alright, looking at 10, again, start by square rooting. Square root of 25 would be 5. Square root of y squared would be y. Square root of 121 would be 11. And then I just follow my pattern. 5y plus 11, 5y minus 11. Now, it doesn't matter the order in which you put them. You could have done 5y minus 11 first and then 5y plus 11 second. It'll be the same thing. Setting HPC equal to 0. Subtract the 11. Add the 11. Sorry, I'm going to do it this way. And then divide. So I would get y equals negative 11 fifths and y equals 11 fifths. Alright, so it's difference of squares. Now the last two are going to involve factor by grouping. So I have 4 terms. So let's go ahead and group like so. Looking at the first 2 terms, I could divide both of those by x squared, right, the smallest variable, or the smallest exponent, sorry. So x squared. That would leave me with 1x and 5 on the inside there. Over here, I could divide both of these by 16, but negative. So negative 16, and that would leave me with x and positive 5. Again, remember, these need to be the same when we factor by grouping. Okay, if not, that means something went wrong. Now, writing my 2 factors. I have x squared minus 16, x plus 5. Now, when I look, I notice that I still have a quadratic here. Okay, when that's the case, we want to see if I can keep factoring. I have 2 terms, so I want to think difference of squares or sum and difference of cubes. In this case, it's squares, right? X squared is a perfect square, and 16 is a perfect square. If I square root both of those, I would get x and 4. So, factoring that piece, I would have x plus 4, x minus 4, and then the x plus 5 from before. Now, setting HPC equal to 0, I would have x plus 4 equals 0, x minus 4 equals 0, and x plus 5 equals 0. So subtract 4, add 4, and subtract 5. So this one has 3 answers. Alright, number 12, let's do the same thing. No GCFs, so we go right into my grouping. So the first grouping, I can take out a 9 and an x squared. So that would leave me with 1x and minus 4. Over here, can't really take anything out, but I need to get rid of this negative, so I'm going to take out a negative 1. That would leave me with positive x and then minus 4. So the outsides, 9x squared minus 1, x minus 4. Again, I'm left with a squared term here, so I still have a quadratic, so I still want to think about factoring. It's a binomial again, so either difference of squares or sum and difference of cubes. I look and see that I have 9x squared, all perfect squares, a minus sign, and 1. 1 is a perfect square, right? 1 times 1 is 1. So if I square root everything, that would leave me with 3x and 1. So I would have 3x plus 1, 3x minus 1, and the x minus 4 from earlier. Setting HPC equal to 0. Subtract. Divide. So x equals negative 1/3. Add the 1. Divide the 3. X equals 1/3. Add the 4. X equals 4. Alright, so that is solving quadratics by factoring.